This is lesson 2.3, Solving Multi-Step Equations. Your objectives are to solve equations involving more than one operation and to solve equations involving consecutive integers. The first method is working backward. Working backward is one of many problem-solving strategies that you can use to solve problems. To work backward, start with the result given at the end and undo each step to arrive at the beginning number. Example 1. A number is divided by 2, and then 8 is subtracted from the quotient. The result is 16. What is the number? So solve the problem by working backward. Start with the final number, which is 16. Undo the subtracting 8 by adding 8. That's the opposite operation. That gives you 24. Then undo the dividing by 2 and multiply by 2 to get 48. So your original number was 48. Work backwards and do the opposite of each operation and do it in reverse order. Example 2. A bacteria culture doubles each half hour. After 3 hours, there are 6,400 bacteria. How many bacteria were there to begin with? Well, since we're talking in increments of half hours, 3 hours is 6 half-hour periods. So we're going to be doing this 6 times. So start with 6,400. And since originally the bacteria doubled each half hour, we're going to do the opposite. Undo the doubling by taking half of the number each time. And we'll do that 6 times. So 6,400 times half 6 times is 100. There were 100 bacteria to begin with. So work your way backwards. Start at the final number and go backwards doing the opposite operation for each step until you get back to the beginning. Solve each problem by working backward. Number 1. A number is divided by 3, and then 4 is added to the quotient. The result is 8. Find the number. To work backwards, start with the final number, which is 8. Now go backwards. If 4 was added to it, do the opposite and subtract 4, giving you 4. Go back the next step. It was divided by 3. You multiply by 3. 4 times 3 is 12, and that's the answer. Start at the final number, work backward doing the opposite operation each step until you get to the beginning. Number 2. A number is multiplied by 5, then 3 is subtracted from the product. The result is 12. Find the number. Well, to work backwards, start with the final number, which was 12. Now work backwards. 3 was subtracted. Do the opposite and add 3, giving you 15. What's the next step? It was multiplied by 5. Do the opposite and divide by 5. 15 divided by 5 is 3. And that's the end. That's the number we started with, was 3. Work backwards doing the opposite operations until you get to the beginning. Number 4. 3 times a number plus 3 is 24. Find the number. We'll start with the final number, which is 24, and now work backwards. If it was plus 3, do the opposite and subtract 3 to get 21. And then if it was 3 times that number, do the opposite and divide by 3. 21 divided by 3 is 7. Start at the final number and go backwards doing the opposite operation for each step. Number 5. Angela rented a car for $29.99 a day, plus a one-time insurance cost of $5. Her bill was $124.96. For how many days did she rent the car? Well, let's start at the end and work backwards. The final cost was $124.96. The one-time insurance cost was $5. That would have been added to the bill. So do the opposite and subtract 5 from the bill, giving you $119.96. The car cost $29.99 per day. So you would multiply that by the number of days. Well, let's do the opposite and divide by $29.99, giving you 4 days. Number 6. Mike withdrew an amount of money from his bank account. He spent 1/4 for gasoline and had $90 left. How much money did he withdraw? Let's start with the final number, which is 90. Now work backwards. He spent 1/4 of it for gasoline. If he spent 1/4 of it, then what he had left was 3/4 of it. So really, $90 is 3/4 of the original. Of is multiply. So we really multiplied the original by 3/4 to get that 90. Well, do the opposite and divide by 3/4. Dividing by 3/4 is multiplying by the reciprocal, so multiply by 4/3. 90 times 4/3. The 3 and the 90 can cancel out a little bit. Reduce it by a factor of 3. So he had $120. You got to think a little bit differently there, because he spent 1/4 of it. That doesn't mean we need to add 1/4 to the number. Take it into context. If he spent 1/4, then he had 3/4 of it left. And 3/4 of the original was times the original. So divide by 3/4 to go backwards. For multi-step equations, they're equations that involve more than one operation. Undo all of the operations by doing the opposite operation. For example, solve 5x plus 3 equals 23. Well, they start by getting rid of the 3. Since the 3 is added, they subtract it from each side. 3 minus 3 is 0 on the left. 5x plus 0 is 5x. And 23 minus 0 is 20. You still have a 5 with the x. That's 5 times x. Do the opposite and divide both sides by 5. 5 divided by 5 is 1, and 1 times x is x. 20 divided by 5 is 4. Always do the opposite operation to move a number to the other side. For multi-step equations, the order we're going to follow is going to be the big ugly fractions, and what that means is a fraction that's pretty complicated, and to fix that you would multiply both sides by the common denominator. Once that's taken care of, do any adding or subtracting, and then finally multiply or divide. Remember, there are several ways to solve equations, but if you follow these steps, it'll work every time. Solve each equation. Number 1, 5x plus 2 equals 27. I don't have any big ugly fractions. I have a number times the x and a number added to it. Do the adding and subtracting first. Since that's a plus 2, do the opposite and subtract 2 from each side. The 2 cancels on the left, leaving 5x. 27 minus 2 is 25. Now get rid of the 5. That's 5 times x. Do the opposite and divide both sides by 5. 5's cancel on the left, leaving x, and 25 divided by 5 is 5. Remember, take care of any complicated fractions first, then add or subtract, then multiply or divide. Number 3, 5x plus 16 equals 51. Do fractions first, there's not any. Then add or subtract. The 16 is added. Do the opposite and subtract 16 from both sides. 16's cancel on the left, leaving 5x, and 51 minus 16 is 35. Now multiply or divide. That's a 5 times x. Do the opposite and divide both sides by 5. 5's cancel on the left, and 35 divided by 5 is 7. Number 7. 16 equals d minus 12 all over 14. Start with any big ugly fractions, and we have one here. To fix that, multiply both sides by the common denominator. Since we only have one fraction, the denominator will be 14, and we'll multiply both sides by 14. The reason that helps us is because right now it's d minus 12 divided by 14. If we multiply by the 14, it'll cancel out and move it to the other side. On the left, 14 times 16 is 224. The 14's cancel on the right, leaving d minus 12. The variable's not by itself yet. You have a 12 that's being subtracted from it. So do the opposite and add 12 to both sides of the equation. 224 plus 12 is 236. The minus 12 plus 12 cancels, leaving d. Number 8. 8 plus 3n over 12 equals 13. Start with any big ugly fractions. We have a fraction, but it's not really that crazy, so we don't need to multiply both sides by the denominator. But I can reduce that fraction. 3/12 is divisible by 3 on each side of the fraction. 3 becomes 1 and 12 becomes 4. So to simplify that a little bit, you now have a 1n on top, which is just n, and a 4 on the bottom. Now, do any adding or subtracting. You have an 8 that's added to it. The 8 is positive. Do the opposite of a positive and subtract it from each side. The 8's cancel on the left, leaving n over 4, and 13 minus 8 is 5. The variable's not by itself yet. It's divided by 4. Do the opposite of division and multiply both sides by 4. The 4's cancel on the left, leaving n, and 4 times 5 is 20. Now the variable's by itself, and you're finished. Number 9. G divided by negative 5 plus 3 equals negative 13. Start with big ugly fractions. We have a fraction, but it's not complicated. Now addition and subtraction. With the variable, the 3 is added to it, so undo that by subtracting 3 from each side. The 3's cancel on the left, and negative 13 minus 3 is negative 16. Now it's g divided by negative 5. Undo the division and multiply both sides by negative 5. The negative 5's cancel on the left, leaving g, and negative 5 times negative 16 is 80. Number 10. 4b plus 8 all over negative 2 equals 10. Start with big ugly fractions, and we have one. Multiply both sides by the common denominator, which is negative 2. That will get rid of the fraction and make my equation a lot easier to deal with. The negative 2's cancel on the left, leaving 4b plus 8, and negative 2 times 10 is negative 20. Now add or subtract. The 8 is added over there with the variable. Do the opposite and subtract it from each side. Now multiply or divide. It's a 4 times b. Do the opposite and divide both sides by 4. 4 divided by 4 cancels out, leaving a b, and negative 28 divided by 4 is negative 7. Number 11, 0.2x minus 8 equals negative 2. There are no big ugly fractions, so add or subtract. The 8 is subtracted over there with the variable. Do the opposite and add it to both sides. The 8's cancel on the left, leaving 0.2x, and negative 2 plus 8 is 6. Now multiply or divide. That's a 0.2 times x. Do the opposite and divide both sides by 0.2. The 0.2 cancels on the left, leaving x, and 6 divided by 0.2 is 30. (14) 8 equals negative 12 plus k over negative 4. We have a fraction, but it's not complicated, so add or subtract first. Since we have a negative 12 that's added to the k, that's a negative 12, so do the opposite of a negative and add it to both sides. 8 plus 12 is 20. The 12's cancel on the right, leaving k over negative 4. Now multiply or divide. That's k divided by negative 4. So do the opposite and multiply both sides by negative 4. Negative 4 times 20 is negative 80, and the negative 4's cancel on the right, leaving your k. Your k is by itself now, so you're finished. K is negative 80. Number 15. 0 equals 10y minus 40. There are no big ugly fractions, so add or subtract. Over there with the y, you're subtracting 40. Do the opposite and add 40 to each side of the equation. 0 plus 40 is 40. The 40's cancel on the right, leaving 10y. Now, multiply or divide. You have 10 times y. Do the opposite and divide both sides by 10. 40 divided by 10 is 4. 10 divided by 10 is 1, which is 1y, and the 1y is just y, so the 10's cancel. The y is by itself, y equals 4. Write an equation and solve each problem. 16. Find 3 consecutive integers whose sum is 96. Consecutive integers are integers that are in order, like 3, 4, 5, 6. They're one number apart. We first need to identify these integers. Since we don't know the first one, let's call it x. Since they're consecutive integers, the second one is one more than x, so we'll call it x plus 1. The third one is one more than the second one, and it's actually 2 more than the first one. We'll call it x plus 2. This is how you set up consecutive integers. The first one is x, the second one is x plus 1, the third is x plus 2. If you had a fourth, it would be x plus 3. A fifth would be x plus 4, and so on. Now these 3 integers have a sum of 96, so let's add them up to equal 96. X plus x plus 1 plus x plus 2 equals 96. Now solve. You have like terms. X plus x plus x is 3x. 1 plus 2 is 3 equals 96. Add or subtract. You've got a 3 added to the x, so subtract it from both sides. The 3's cancel on the left, leaving 3x. 96 minus 3 is 93. Now multiply or divide. You've got 3 times x, so divide by 3. X is 31. And that's the first of the 3 integers. The second one is one more than that. The third is one more than that. So your three consecutive integers are 31, 32, and 33. (17) Find two consecutive odd integers whose sum is 176. Odd integers are like 3, 5, 7, 9. They're 2 units apart. We don't know the first one, so we'll call it x. And since they're odd, the second one is 2 more than x. Notice, on the last question, consecutive integers, the first was x and the second was x plus 1. If they're odd, the first is x and the second one is x plus 2. The third would be x plus 4. The fourth would be x plus 6, and so on. This same method is used for consecutive even integers as well, because they're 2 units apart. Now these integers have a sum of 176, so let's add them up to equal 176. X plus x plus 2 equals 176. You have like terms there. X plus x is 2x. Now add or subtract. Subtract 2 from each side. The 2's cancel, leaving 2x, and you get 174 on the right. Now multiply or divide. That's a 2 times x, so do the opposite and divide by 2. 2's cancel on the left, leaving x, and 174 divided by 2 is 87. So the first number is 87. They're odd, so the next one would be 89. Remember, when they're consecutive odd integers, add 2 to get the second one. Number 18. Find three consecutive integers whose sum is negative 93. Consecutive integers are like 4, 5, 6, 7, in order, one number apart. We don't know the first one, so it's x. The second one is 1 more than x, x plus 1. The third one is 1 more than that, x plus 2. Those have a sum of negative 93, so let's add them up to equal negative 93. Get your like terms together. X plus x plus x is 3x. 1 plus 2 is 3. Now subtract 3 from both sides, and 3x equals negative 96. Divide both sides by 3, and x is negative 32. So the first one is negative 32. The second one is 1 more than that, negative 31. And the last one is 1 more than that, or negative 30. So, to start, we worked problems backwards. We started with the final number and worked backwards, doing the opposite operation of each step until we got to the beginning. Then we started solving multi-step equations. You start with big ugly fractions and multiply both sides by the common denominator, then add or subtract, then multiply or divide. With consecutive integers, the first one is x, the second one is x plus 1, the third is x plus 2. Or if they're even or odd, the first is x, and the second one is x plus 2. The third would be x plus 4. If it says their sum is something, add them up to equal that, and solve the equation.